Welcome back to another video in our functions unit. This one is on step functions. Let's take a look. Now, some good news here. Step functions are actually going to give us a break from the formulas and the rules that we're used to using in the topics that we learn. Now, step functions are obviously a relationship between x and y because all functions are. But this one, we aren't going to follow a rule or an equation to help us through the question. Now, the idea here in step functions is that we have x values that change, and the y values change accordingly, but those y values change in steps or intervals, kind of jumping from one y value to another according to those x values. Now, the easiest way to understand this is to see how it looks on a graph. Now, the situation that you see on the screen here represents the cost of entry per person to an amusement park based on the number of people that show up in your group. So as we would expect, and you can see by these descending steps here, the more people that you have in your group, the less that the cost of entry is per person in that group. Now notice I keep emphasizing the per person cost here. We're not looking at a total cost for a group. We're talking about the admission price per person to the amusement park. So this is the amount that each person pays to get in. Now notice how the graph looks here. I've kind of got a series of steps, a little mini staircase here to show the cost per person according to the size of the group. So now let's look at that first step here, the step that represents the cost per person for a group that ranges from 0 to 2 people. Now, of course, this step starts with an empty circle at 0 people. Of course, if you've got 0 people going to an amusement park, you can't have a cost of admission for nobody. So remember what the empty circle means. It means that we do not include that value in our function. So at 0, we don't have a value for y. There is no cost for no people. So here, this is helpful if we look at the graph. If I try to read the value at 0 for x, I'm going to go up and I pass right through that empty circle. I can't stop and read at an empty circle because I don't include that value on a graph. So if I try to read my value at 0, I just keep on going through the empty circle and I don't have an amount for y. So when I read these graphs, if I've got an x value that I'm interested in finding out the y that goes with it, I can read up from the x value and I only stop and read the graph if I hit a step, those are the horizontal lines, or a full circle like you see at the right end of this first step. So this first step from 0 to 2, because I have that empty circle at 0, the first step really represents a group size of only 1 or 2 people paying $50 each. And my next step, notice that it starts at 2, but it starts with an open circle. So if I was reading the price for 2 people, I would pass right through that open circle and go up to the $50 amount. So the second step, even though it looks like it ranges from 2 to 4 people, actually only includes the admission price per person if I had a group size of 3 or 4 people. 2 is not included in this step because of the open circle. Now I'm going to create a table of intervals here beside my graph. This is just to show you that we don't have to have a graph for a step function, though it certainly does help us to see it better. The table, though, is going to make the steps on the graph a little bit more clear. When I make intervals out of it, there's a clear starting and ending point to each of those steps. Now you have to remember those square brackets that we learned about. My first interval here, my first step, is from 0 to 2. But notice when I write the interval, I'm turning the square bracket away from the number 0. That means I'm not including 0 in that interval. The bracket turned away means we don't include that number. We start just after it. So that first step had an empty circle at 0 and a full circle at 2. Notice the matching interval has the bracket turned away from 0, but the bracket hugging the 2 to include it. So my next interval here is from 2 to 4, but notice the bracket's turned away from the 2 because of the empty circle on the graph, and the bracket includes the 4 because there's a full circle at 4. Now I can never include the same x value in 2 different intervals. Let's say I included the 2 here. We wouldn't know how much each person pays in a group of 2 because it would belong to the $50 price and the $40 price at the same time. The same group of people can't pay a different amount each to get into the amusement park. Now I'll finish filling in my table here. As groups larger than 4 but less than or equal to 10 people are going to pay $30 each to get into the amusement park. And any group that's larger than 10 people is just going to pay $20 each for admission. Now notice in that table of intervals, every time I had an open circle, my square bracket was turned away from the number, meaning I don't include it in that step. Anytime I had a full circle, I hug the number to show that I'm including it. Now take a look at the last step on my graph and the last interval in my table. That last step goes on forever. Look at the arrow on the end of the line. That means that line keeps on going. So any group infinitely large that's bigger than 10 people is going to pay $20 each person. And that means the interval that represents that step can't have an ending point. It goes on until infinity. Now, what I have to point out about this example specifically is that obviously in this case, we can't have a decimal value. We can't have some portion of a person. But if we did have an instance or an example where we did have decimal values, we would go to wherever that decimal is on our x-axis, read up, and find the y value that corresponds. We would stop at either a step or a full circle and read the y amount that corresponds with that x value, whether it's an integer or a decimal. So that's all we really need to know about step functions. We're usually given a graph, but it could be in a table of intervals representing the steps of y values that correspond with any x value. And remember, in this course, we're only going to have to interpret these step functions. There is a rule that goes with it, but it's pretty long and complex, and it doesn't apply to this course, so we don't care about it. Now, the little things to watch out for here, be careful of those open circles. Those values are not included. So if you're reading your graph, pass right through those open circles until you hit a full circle or a step. Only those values get included. Remember also, we can never have two full circles that are lined up right over each other, and no two steps can ever overlap. In a case like that, we wouldn't have a question that makes any sense at all. When we're trying to read an x value, we can never have two y values to choose from. That doesn't make any sense. There has to only be one y value for any x value that we're trying to read. And using the example we just looked at to explain this, well, you couldn't have two different admission prices per person for two groups of the same size. Now it's time to check out an example of step functions to make sure we're all clear on how they work.